G'day and welcome to 12 Volt Shed, and I'm very pleased to say this is the very first 12 Volt Shed interview. I'm here in Clayton in Melbourne, Victoria with Darren Helleren from Retrolooms. Darren, you've been in business for what, 16 odd years?
16 to 20 years in this industry, yeah.
And what do you do?
Basically play around with anything with electricity in it.
And you said to me a great thing, if electricity flows through it, these guys do it. Look, some of you will know Retrolooms. Some of you may have even had a vehicle or a caravan in here. Darren and the team are probably well renowned Australia-wide for being the guys who can fix things. They're Victron agents, so they're well versed with inverters, with in DC-DC charging, solar, in caravan, RV and four-wheel drive applications. So
all your batteries and solar panels and all that sort of stuff, yeah.
Battery, solar, the lot. So what, Darren, you've obviously been in this game a long
Just
time.
a little
now,
bit,
a little bit. We're surrounded here by terminals. Being the name Retrolooms, you guys obviously make a few.
We make
things.
wiring harnesses, yeah.
So you're not a novice at this. So
no.
What's some of the common stuff that you see come through the door?
We fit a lot of caravans with inverters, upgrades on solar. A lot of 4Bs come in. We do the upgrade to DC, discuss with the customer if they actually need one or not. Different types of batteries. We do upgrade to lithium batteries if necessary. A lot of that stuff is it sort of suits in with what the customer needs.
Yep.
A lithium battery is not the be-all and end-all of an upgrade. There's some jobs that are well suited for AGM batteries or wet batteries, for argument's sake, the old school.
Yep.
Some vehicles need DC to DCs, some don't. Some people just waste their money putting a DC to DC on a system that has got no requirement for it.
A VSR relay or even
a VSR will work quite well.
Even a marine switch in some
Exactly.
applications. Yep.
So a lot of that stuff comes down to discussing with the client what they want to get out of the particular thing they've got and future scope. If they come to me and say, in the future we want to add this and this, right, that changes the whole design of the project.
Yep.
But as far as it's a matter of matching up the equipment that the customer needs to do the job for the least amount of money they need to spend. If they want to spend a ton of money, I'm happy to help them.
Yeah, you'll help part them with their hard-earned coin. No, it's a good point you raised, because a lot of people tend to create a bit of overkill or overcomplicate a system.
Yep.
That's what I find guys like yourself over the years, and it is a bit of a plug for Darren and the team. You know, they are very knowledgeable guys, and that you'll hear me always say to people, if you don't know what you're doing, seek an expert, because you can cost yourself a lot of unnecessary money. But I know you're, we've talked a lot about DC charging and some of the common stuff we see with that. Earthing, for example, is probably one big thing that people get wrong. And earthing, what sort of issues do you see with earthing? What consequences?
Well, if you end up with a bad earth on your DC to DC, the whole unit's not going to run right. Some models will completely overcharge. You can have a 24 to 12 volt DC to DC on a truck. You take the earth away and you got 24 to 24 volts, so you're going to fry your batteries. It's a classic, it's only the earth scenario, when yes, it's the major thing. It's like saying, do I need a fuse or not? Well, do you want a fire or not, is the answer to that one.
That's right. Very true. And tell me, solar panels.
Yep.
I've spent a lot of time talking to people about, they read the voltage on their solar panel. They got 3 panels and their battery's not lasting, but they, one's died, it's got a diode gone, or what's some of the common stuff you see with solar?
Bad connections would be a classic of solar panels. People trying to put the MC4 as a standard international solar connector for connecting panels. People crimp them on themselves and they don't connect properly. The wires fall off. They don't crimp them properly with the proper tools. Screw connectors laying in the junction box full of water, corroding away. You can't beat soldering the wires, yet if you put a proper waterproof connector on and do it properly, that's brilliant, because it gives you a test point. Once you solder it, cut it, solder it, you've got to cut it to test panels. So yeah, panels, predominantly one of our things. If we have 3 panels on a job, they're all in exactly the same plane, we'll quite often series them up and use a really good quality MPPT controller from Victron or Enerdrive, or one of those guys, that can handle the voltage from the panels. One thing we've got to keep in mind. But if they're all on the same plane, you get, it's only a bit of shadowing will affect it. But if they're all on different angles, well then they potentially all need their own solar controller. And that's one of the things that people don't sort of understand or follow.
Show me this, because I know you want to show us this.
Oh, this is just one of the little DIY things we make for different customers. It's for a caravan.
Well, you might hold it up. This is a shining example of the difference between something I might do in the shed at home and the difference that Darren and the team will do, just the way the wires are laid out and everything. This is a basic install for a guy building his own camper trailer or thing. He's got a 17 amp battery charger, an 18 amp Victron DC to DC unit. Now that's not a multi-stage charger, it's just a 1-stage charger, a 20 amp solar controller, a battery monitor, shunt for a battery monitor, and easy points to connect. So you connect your solar panels to these two, your Anderson plug to these two, and these two are out to your accessories, your fridge and your power sockets. Is this something you guys make here? We make these and sell them as an assembly. This is fantastic, because this could be a caravan, an RV, a boat. Camper, it could be a tin shed up a bush block. I mean, yep, exactly. You know, that's a fantastic little setup. And we adapt them. We just did one for a job where we actually, instead of a battery charger, we put a 2000 watt inverter charger. Yep. And a 30 amp DC to DC and a 30 amp solar controller on it. Well, that's what I was saying, isn't it? The 4-page white, and look at the quality of that. The workmanship is beautiful, mate. So, DC charging is obviously, it's a pretty popular topic on my site. And it's something as you know, we've spent many hours talking about. A lot of chats. A lot of chats. A lot of froths go past that chat. I've recently done a comparison table, and one of the big things I noticed is the real variance in what people consider the right voltage to be. So I've got 12 different manufacturers with probably maybe 9 different voltage settings across all these different things. So it all comes down to what battery you're using. Every battery manufacturer specifies a voltage they want their battery to be at. Yep. Quite often, if you narrow it down, there's a standby voltage and a cycling voltage. So you'll have a voltage set for floating, so it's in standby and sitting there not doing anything. And then you'll have a voltage set for actually charging the battery. Now, some DC-DCs are a single voltage charger, which that one is. Yep. So that we just set to put out a float voltage. So what that means is you're driving along and it's not going to hard charge your battery, but it's going to get 18 amps because your battery's gone flat while you've had your fridge on for 3 days. You start the car up and you drive along, you'll be getting 13.8 volts at 18 amps out of that, and it'll bring the battery up to about 85%. Then when you pull up and the sun's out, the solar regulator's a bit that tops it up. So we're looking at sort of a bulk initial charge with the DC to DC, and this has a solar controller that brings it up to the float voltage. It'll actually boost the voltage up a bit to bring that up as fast as it can and then finish the charge off. But the bulk of it's been in through the DC to DC. That's on a system with a solar controller. Yep. If we had a system where we don't have solar, well then you want the DC to DC to do the whole job. You want it to bulk charge it, absorb charge it, and then float it at the end and finish it off. So that's where you want a 3-stage DC to DC. Yep. So in our eyes, it's horses for courses. If you've got a heap of solar on your van, why put a very expensive 3 or 4-stage DC to DC of 40 or 50 amps when you only want it to fulfill a void, start topping the tank up in the battery while you're driving along, and you might only drive for 4 hours a day. Well, you can't fill a battery up in 4 hours. No. You might be able in a lithium with a massive big DC to DC, but you start talking huge dollars. So if AGM,
a standard one-stage DC charger that brings it up and then the solar finishes it off. It seems to work really good on a lot of cases.
On that topic, I've had a few people comment to me about lithium and it being a bit hard on alternators because it can take a hell of a lot of current.
It'll kill an alternator.
So, yeah, it's important.
You put a charged solenoid, put a charged solenoid straight to a lithium battery, and the lithium battery is like a black hole for power. It just takes whatever it can get. Yeah. So it'll load a 100 amp alternator up and pull 100 amps out of that alternator until it starts to smoke.
Yeah, right.
Now, things will change a bit because you go cable size, length of cable, introduce some resistance in there. You won't get your 100 amps until the voltage drops off, but the alternator will be working hard.
Yeah.
So a DC to DC is a current regulator. Yeah. So it will take the amps of the alternator, and if it's a 50 amp DC to DC and the voltage drops off, it can do 50 amps into the battery. Yeah. But if you've got a 100 amp alternator supplying it, it's never going to overload the alternator.
Yeah. So it's really important that
on lithium,
especially when you start playing with lithium, and lithium's a great product, that you make sure you get that kit right and that you set it up right. Talk to me about cable sizing. If I said, an underbonnet install, we're not a long way from the start battery, what would your standard cable size be for a second battery underbonnet?
So here's the questions come up again.
Yeah.
Are you running the second battery just to run your fridge?
Yeah.
Are you planning on using your second battery to jumpstart your first battery?
Yeah. No.
Oh, maybe we are. Yeah. Okay. If you're going to pull the starter current back through your charge solenoid, or you put a solenoid on it to jumpstart yourself, then you're going to need battery cable.
Yeah.
If you're just running your fridge and you got a 100 amp alternator, which is standard on most 4Bs at the moment, then you've got an AGM battery, which is normally not put under the bonnet, but we find a lot of them there anyway. And if you're happy for the time they last, by all means, I'd be running something like a 16mm squared cable from one to the other, which in entirety on a length of 2 meters will happily carry about 100 amps.
Yep. Couldn't agree more. And don't forget the fuse
each end.
Circuit breaker.
Don't forget a fuse each end, because you cut the cable, you've got power coming from both batteries.
Yep.
So same as if you put a battery down the back and a battery up the front, it's a fuse each end.
I always recommend at least a mega fuse behind your 50 amp Anderson plug or something, a circuit breaker, anything. Do you prefer circuit breakers or fuses?
I prefer fuses, because then you can go looking for what happened instead of finding the remnants of a burnt carcass of something later on after the circuit breaker's been sitting there snapping in and out.
I like I personally like the Busman positive, the little yellow button with the lever.
Perfect. If you got the space and you want to, the Busman breakers or some of the high end stuff is really good with the manual reset.
I find some of the cheapy, the Chinese knockoffs get a bit hot. They get quite warm with a bit of current flow.
Yeah. A fuse is a whole topic for another day. But one of the things with fuses is the material they're made out of. So if you have a really bad fuse, a fuse naturally puts voltage drop across the circuit. That's how it works. But if you use good quality materials that don't generate a lot of heat other than a little fused area, it's good. But the cheaper fuses seem to heat up the whole connector and melt everything. Anyway,
we'll pause it here because there's a shower.
Bit of Melbourne weather.
That's all right. We can. I'll just let it roll. We're at 14 minutes, so we don't want to go too long anyway. Yeah. All right.
So,
okay, so fusing, circuit breaking, cabling, they're probably some of the common things that I see. I mean, I had a lovely gentleman write to me once, he got a van burned to the ground that he'd rebuilt, and he didn't have a single circuit breaker or fuse in the whole van. He wired it all straight back to the battery. So, really important, fuse.
Always put fuses. Yeah. Cable protection is something that's overlooked a lot.
Yeah.
You buy a roll of wire, it's got an insulation over the copper. You run it through your vehicle.
Yeah, chuck it down the chassis rail.
Chassis rail. It sits there and vibrates.
Yeah.
Diesels.
Yeah.
We know, but a lot of may not, that a diesel sets up a really high frequency vibration. If you look at any of the industrial machines, William Adams, any of those companies that do big machinery, they've always got a braiding over their loom to stop the loom rubbing through on surfaces.
Yep.
So with our four-wheel drives, you lift the bonnet and there's a lot of people, here's just wires run everywhere that are rubbing through, shorting out. So you really want the idea of an insulation, whether it be what we don't generally like is the split tubing, because it's sort of used over everything and it doesn't do a lot, but it's better than nothing. When you use an insulation like that, or a PVC sleeve or a fiberglass sleeve,
if you don't use split tube?
we use a PVC sleeve. Probably somewhere in the workshop we've got
Darren's
a piece.
about to walk off camera and get some, but that's okay.
Get a bit of PVC.
So righto, so Darren's back with this. So yeah, literally, I'll do a close-up of this, but yeah.
It's your cheapest form of insulation, short of having that split convolute that you can buy everywhere. PVC, lightweight, predominantly black. The idea with the insulation is, if you've got an edge, will grip the insulation, but the wire can move freely inside it. So over a long period of time you can chafe through that, and then it may start on the wire. But it's the same with anything. You pretty much quadruple the life of any piece of wire by putting a sleeving over the outside it.
Yeah. And I personally like the P-clamp as well.
Definitely
I love my
P-clamp.
rubber insulated P-clamps.
Cheaper option is a nylon P-clamp.
Yep.
Does are really good, but not as robust.
Yep.
If you're doing inside your camper or something, nylon P-clips are great.
Yep.
Doing along the chassis, you really want some rubber coated P-clips.
Yep.
Bolted into a decent part of the chassis or the bodywork. Definitely space them sort of around the 200mm apart, and you don't get sagging.
And having been a man around wire for a while, wire's not wire. I mean, I've seen double insulated wire sold as, you know, this gauge or that gauge, but it's actually the double insulation that's made the gauge, and the copper inside's not as good. Or are you seeing rubbish wire these days? Is there, you know, I've heard there's a lot of tinned wire getting around.
Well, there's tinned wire. Tinned wire is always nice.
Or tinned for marine.
Usually more expensive, but yes, definitely really good in marine. There's still a hell of a lot of wire made in Australia. We have 3 wire manufacturers in Australia that I know of.
Yep.
Probably 4 if you go to household, but manufacture of automotive wire. We've pretty much got place with 3 big plants. And they make a really good high quality. The insulation's up to international standards. The copper's really good quality copper. You'll find, if you ever strip a piece of copper wire and you find there's a black strand in it, just throw it in the rubbish bin.
Right, that's a good tip. Great tip.
That black strand is a contaminated piece of copper. When they make copper wire, each strand of wire is extruded from 1 bar.
Yep.
If that bar's got contamination on it, you'll end up with 4,000 lineal meters of contaminated copper strand.
Yeah, right.
You put that in a bunch with the other 26 copper strands that go in for what we call an auto 4mm cable. It will transfer its blackness to all the others, like you find in some boats.
So when you say black, not a black wire, but the internal
copper
is black.
1 strand looks black compared to all the others,
So just
and
throw
it's
it over the
tarnished,
shoulder.
and it's shot.
Yeah, right. Well, that's a really fantastic tip.
And when you go and crimp that, if you strip a wire and you find they're all black, which you'll find on a lot of boats or old wire, crimp a turbine, you instantly got a high resistance joint, because you're actually crimping against all the tarnish.
Yes.
If you've got to use it, you sit there for a period of time until you get rid of the black tarnish off it, and if you can, solder it, because you can get a decent connection.
Yeah, I have heard that about the boats. That's a common problem in boats. People crimping old green.
Yep.
You know, the cable's pretty much dead.
Yep.
They cut back a foot and still green, so they just think, oh well, I've run out of length, so I'll crimp it.
Yep.
But yeah, you really are better off taking the time to get rid of that cable.
Bad cable. But yeah, main issue is people using undersized wire.
And crimps, that's the other thing. My personal hate in the world of things is those yellow crimp terminals, because once you get to that size, you really should be soldering, and people tend to crimp. And there's two sizes. There's the fat one, and then there's the one that's skinny.
Well, in the crimp terminal market, that stuff's available out there at all your Super Cheap Auto Barns, all Repcos, all that stuff. There's a high-end terminal and there's a low-end terminal. Now, a high-end terminal, if you find them, if you pull the yellow bit off, you'll find there'll be a copper sleeve over the top of the other crimpy bit.
Those,
okay,
yep.
That's a high-end one. They're used mainly in 240 volt.
Yep.
They're really good quality, but they're about 5-6 times the price.
Yeah.
In the Chinese market, you get the cheaper ones, which just have the plastic yellow bit over the terminal, and you squeeze it down and crimp it.
Yep.
They work fine, but you're still only squeezing 2 bits of. You're not making a really good connection. Yeah. If you ever see a wiring harness that's made by a loom manufacturer, the crimp will be basically an M shape that'll crimp down and lock the wire in. Yeah. It's a much better terminal, much better cross-sectional area.
It comes down to the crimping tool.
The crimping tool.
Yeah.
You can buy them, but most people don't, because they're like $160 for a pair of crimp pliers.
Yeah.
And they're not. The terminals aren't available everywhere, so you've actually got to come somewhere like us, and there's a lot of other companies around. Autolex will have access to them. So we're back to the common red, blue, yellow crimps.
Yeah.
You can. There's some really reasonably good ones out now that have got heat shrink tails on them.
I have seen those. I haven't used them yet myself, but I have seen
a lot of the marine guys use them because they're very convenient. They can crimp them on, heat them up, shrink it down, and it pretty much insulates the moisture from getting into the wire, whether it be tin, copper or not. Yeah. They work quite well. Once again, they're a little bit more expensive than normal crimp. Yeah. Terminals as a whole.
It is. You could make a video on terminals and soldering and crimping.
And
we probably will at some point do a bit of a.
We've got a few samples here. We
just a couple of terminals, mate.
Yeah.
Well, look, I mean, I won't. I'll wrap it up. I mean, we could literally talk for days on all sorts of topics, but I really appreciate your time, and I really appreciate you being the first of our interviews.
I appreciate being asked first,
mate. It's a pleasure. I think everybody here will get a little bit of something out of that.
Yeah, hopefully.
And hey, if you need a good system designed, if you're after a Victron system, you need some looms made. Retrolooms, the website
www.retrolooms.com.au.
We'll put it down the bottom here. Retrolooms.com.au.
Yep.
Thanks, mate. Really great.
Cheers.
Pleasure.
Thanks for coming down.